Hey everybody, welcome to week 3 of quarter 3, 3 and 3. That's awesome. And welcome to Earth Science. I've done things a little differently this week because we've gotten into the semester a bit and I needed to organize my thoughts. So I have some slides ready for you to go over what the learning objective is for this week and what I expect of you. So number one, you are going to construct a scale model of our solar system by measuring the distances related to 1 AU, which is the distance from the sun, and the diameters of the planets related to 1 Earth. And the scale that you're going to use is listed here as 1 meter is 1 AU, so that's the distance of the Earth from the sun, and 10 centimeters is the diameter of 1 Earth. And for this purpose and for this class, we're going to treat the orbits and the planets as circles. That'll make things a lot easier. They are not in real life, but for this activity we will. And it is my understanding that this was not done last week yet, so you will do that this week. That is your goal. And I will need photographs of your completed models, even if they are in pieces, because they're going to be quite big, and I need to see each part of it. You can do a picture like at a distance to show me. You can show me the inner solar system as best as you can. And then you can also show me a wide angle of the outer solar system. I'm going to go over some of the corrections to your misconceptions. I received several assignments from students, but not everybody turned this in. There were also some incorrect answers on those assignments that were turned in. So I want to go over those misconceptions with everybody so that everybody has the same answers. I also would like to remind you that there is an extra credit video on the classroom that I'd like you to go look at. I got something in the mail that is not to scale, and I'd like you to correct that. So please go ahead and look at that. I'm going to show you on the chart that you have in the classroom how to get to other charts, because I need you to find one chart in order to make your model. And you're going to use that chart and become very familiar with it. Also, this Friday is a half day, so please remember that. Please organize your week that way, around that. And Saturday is a Beat Back Bufflegrass Day, our annual Beat Back Bufflegrass Day, and our second work day out at the Swan Wash Project. I will be there on Saturday coordinating the sign-in sheets and the liability sheets because I need to, and because there are two things happening at one time, and I want to make sure that everything is done correctly. So I will be at the school coordinating the sign-in and dividing up of the teams. So before I get into the corrections for the misconceptions, I want to show you where this chart is. So if you go into your classroom and you go onto your chart that says the planetary fact sheet from NASA in metric, and you click on that sheet, it'll open up that planetary fact sheet in metric, and you will scroll down to where it says planetary fact sheet values compared to Earth, and you will click on that. And what you will see here is that the Earth is all ones. And so we're going to use the Earth as our scale. Everything is compared to the Earth. So let me go over this very quickly with you. So for example, 1 Earth right here, when you're looking at Venus, it is about, these are in decimals, so it's about 95% the size of Earth. So whatever you decide Earth to be, if it's 10 centimeters, then Venus will be around 9.5 centimeters. Mercury, on the other hand, will be about, 9.5 centimeters. Mercury will be about 3.8 centimeters. If you think of this as money, it's the best and easiest way to get through this. So the Earth would be like $1. Venus, when we're talking about the diameter, it would be $1. Venus would be 95 cents of that dollar, and Mercury would be 38 cents of that dollar. And I'm asking you to use a 10 centimeter section for Earth. That way you can use those centimeter marks and the millimeter marks to do the correct diameters. Once you get a ruler, it'll make more sense to you. As you go out, you'll notice that Jupiter, for example, is much larger than Earth. It is 11 times bigger than Earth. You can go ahead and round this. Saturn is about 9.5 times bigger than Earth. Uranus is 4 times bigger than Earth. Neptune is a little smaller than Uranus, but not quite Uranus's size. And then you are going to include Pluto. So please make sure you do that. There are a couple of ways you can do this model. Number one is you can do concentric circles representing the sun, which is 110 times bigger than Earth. So that would be, if 10 centimeters is the Earth, multiply that times 110, that'll be the diameter of the sun. And you would draw a circle to represent that sun. In the middle, you would put the smallest planets, and then you would put Venus. Well, Pluto would go in the middle because it is the smallest, and then Mercury, Venus, and keep going out in sizes with that diameter. And they should all fit within the sun. That's how big the sun is. It's humongous. That's one way. Another way to do it is linearly, to show that the distance from the sun, 1 AU, is going to be 1 meter. So you will use the length of a meter stick to indicate the distance of the Earth from the sun. And you would use this row. So if you notice, Earth is 1, and that'll be your 1 AU. And if we think of this as money, Earth is $1. So it's 100 centimeters. So it's just like 100 pennies. So Mercury would be 38 pennies on that meter stick. And you have to figure that out, where that's going to be. Work together. It's not that hard. Venus will be 72 pennies. So it's inside where Earth is here, where my elbow is. The sun is here, where my hand is up. And Mercury and Venus would be inside that place. As you're moving out towards Pluto, you're going to get more space between the planets and further away from the sun. All right, I think that covers that assignment, and please take your time because your measurements are super important for me. I'm going to go over just some of these misconceptions very quickly. Number one, the Earth is closer to the sun during the summer, and that is why it is hot. I'll let you read this on your own. This will be posted in the classroom, but I want you to look at this diagram. And what you'll see here is that the Earth's orbit around the sun, its revolution around the sun, is not perfectly circular. It is an ellipse. And in an ellipse, there is a longer axis and a shorter axis. And it turns out that the closer the Earth is to the sun happens in January, and the further away Earth is from the sun happens in July. It's opposite of what we think. But I need you to understand that in space, when we're talking about thousands of miles, this is 147 million miles, and this is 152 million miles. That is a total of about 5 million miles difference, and it really doesn't make that much of a difference in space when we're talking a million miles. On Earth, it would. So this does not affect the temperature. It actually has to do with the tilt of the Earth. The way the Earth is tilted, 23.5 degrees, and where it is in that orbit. So the Earth never changes the way it is tilted. It'll always look like this, but it will always go around the sun in this direction, counterclockwise. And so sometimes the axis is tilted towards the sun in the northern hemisphere. That is our summer. And sometimes the Earth is tilted away from the sun, and that is our winter. If you need to use your hands, I recommend it a lot because it will help you a lot. The second question was about the sky is blue because it reflects the ocean. That wasn't a question, it was a misconception. And a lot of you who submitted your assignment got that right. It does have to do with the light coming from the sun being all the colors of the rainbow, and that our atmosphere traps some of the shorter wavelengths, which are the purples and the blues, in the atmosphere, and it is the reflection of those light particles off of the gas molecules that are there that scatter that blue color. There's a diagram here, so a very simplistic diagram. You would need to study optics, which is a form of science, in order to understand that a little bit better.